Attributable risk and number needed to harm. Welcome back to our Chalk Talk series on statistics. In this episode, we'll delve into the attributable risk. To do so, let's first quickly recap the last episode using the example of the fictional study on smoking as a risk factor for lung cancer. The study analyzed 100 smokers and 100 non-smokers. The risk of smokers developing lung cancer was 20 out of 100, or 20%. The risk for non-smokers was 2 out of 100, or 2%. To compare both groups, we can calculate the relative risk. This is done by dividing the risk of the exposed group by the risk of the non-exposed group, which gives us a relative risk of 10. Let's move on to the attributable risk. The attributable risk is an additional means of comparing both groups. It's the incidence of disease in the exposed group that can be attributed to the exposure. The risk of the non-exposed group is subtracted from the risk of the exposed group. So, 20% minus 2% equals 18%. How do we interpret the attributable risk in our example? Smokers develop lung cancer in 20% of cases, whereas non-smokers develop lung cancer in only 2% of cases. The difference between both groups is 18%. The attributable risk implies that 18% of the study population developed cancer as a result of smoking. From the attributable risk, we can also calculate the attributable risk percent. This value is calculated as the attributable risk divided by the incidence of disease in the exposed group. In this case, it's 18% divided by 20%, which is 90%. This attributable risk percent of 90% implies that cancer development in the 90% of individuals that smoked was indeed due to smoking. Okay, now we've come to another measure that can be determined from the attributable risk, the number needed to harm. In epidemiological studies, the number needed to harm is often abbreviated as NNH. It's the inverse of the attributable risk, that is, 1 divided by the attributable risk. In our example, the attributable risk is 18%. The number needed to harm is calculated by dividing 1 by 18%. 1 divided by 0.18 is approximately 6. Through its name, the number needed to harm reveals how to interpret the calculated number. So, based on our study, if 6 individuals start smoking, then 1 will eventually develop lung cancer. There is also a closely related value for the number needed to harm that emphasizes another measure, the number needed to treat. But before we delve into it, we need to go back to the attributable risk. We previously mentioned that the attributable risk is the difference in risks between the exposed group and the non-exposed group. The attributable risk is mostly used as a measure of effect size for risk factors. Correspondingly, there's also the absolute risk reduction. It's calculated as the difference between the non-exposed group and the exposed group and is usually used as a measure of the protective effects. We also previously stated that the number needed to harm is the inverse of the attributable risk. Now, the number needed to treat can be calculated in the same way as the number needed to harm, but rather from the absolute risk reduction. The number needed to treat is the average number of patients who need to be treated to prevent one bad outcome. Now, a note on the range of values of the number needed to treat. The number needed to treat can have a value ranging between 1 and infinity. The ideal therapy has a number needed to treat value of 1. It would achieve the desired effect for every individual. In contrast, a very high number needed to treat value indicates that many patients require treatment to achieve success in a single case. So, as a general rule, the higher the number needed to treat value, the less effective the treatment. Great! We're glad to see you've made it so far. Now, let's recap the most important points in this episode. Remember that not only can you compare two groups by dividing their absolute risk values, but you can also calculate the difference between both risks, the attributable risk. The attributable risk percent is calculated as the proportion of cases in exposed individuals that can be attributed to the exposure. Dividing the number 1 by the attributable risk gives you the number needed to harm. The absolute risk reduction and the number needed to treat work in a similar way, with the exception that they're usually applied to protective events. Now it's time to put this knowledge into practice. Let's look at another case study. In a randomized control trial, 432 patients that had undergone upper abdominal surgery were examined. The aim of the study was to determine whether the occurrence of postoperative pneumonia can be prevented by performing physiotherapy before surgery. Of the 218 patients that underwent preoperative physiotherapy, 18 developed pneumonia, whereas of the 214 patients without preoperative physiotherapy, 42 developed pneumonia. Calculate the percent reduction of the risk of pneumonia using physiotherapy. Don't forget that you first need to calculate the risk in the group with physiotherapy, followed by the risk in the group without physiotherapy. We'd also like to know the number needed to treat. Good luck!